Hello, everybody. Welcome back to our next lesson. This lesson begins on page 23 in your notes. And what we're going to be doing today is we're actually going to be drawing the graphs of y equals a times the sine of bx plus c, and y equals a times the cosine of bx plus c. I think I'll do the first video with the sine graph, and I'll do another separate video with the cosine graph, rather than have them like a video that's too long. Now, in our last lesson, we learned how to take the equation of either one of those functions, and we learned how to calculate the amplitude. That's just the a that's in front. If it's a negative, the amplitude, you just drop the negative sign. That's what the absolute value means. To calculate the period of your function, it's always 2 pi divided by whatever the b is, whatever number is in front of your x. And finally, to calculate the displacement or the phase shift, that would be like your horizontal translation, your movement left or right. It's always negative c divided by b. All right, and that's what we learned how to do in our last class. Those calculations are going to be absolutely vital when it comes to sketching the graph of y equals sine x and y equals cosine x. So like I say, we'll do sine x here right now. And what are we going to do? How are we going to do this? Well, you're going to be making up a table of values. And in the table of values, you're going to have 5 points. Points 1, 2, 3, 4, and 5. And you can clearly see them labeled right here. Here's what we're going to call point number 1. They've actually not quite labeled them correctly in your diagram. There's point 1. Point 2 is going to be a maximum. Here's point 3. And you can see point 3 for the sine graph is actually has a y value of 0, doesn't it? Halfway up your curve. Point 4 that you're going to be plotting is the minimum, and point 5 will go up to a maximum again. The graph that they've shown you right there, that's the graph of y equals sine x. So that's what we're going to do, everybody. We are going to be using 5 points, and that's where you're going to get your table of values. All right, 5x values and 5y values. The y values are actually pretty straightforward. There's no real calculations involved with the y values. The x's, yeah, there will be. The x's will have some calculations involved, because the y values, basically, there's 3 of them are going to be 0, and one of them is going to be a maximum, and one is going to be a minimum. And that depends on your amplitude, doesn't it? How high and how low your curve is going to go. All right? The x's, like I say, they're going to be a little bit trickier. Notice that, again, I want to point out that for the sine graph, because the sine graph goes through 0, 0, that's what we're going to consider to be our starting point. All right? Because that point there doesn't change with any kind of a stretching, with any, like a vertical or horizontal stretch. 0, 0 stays put. 0, 0 does not move. You can tell how far left or right your graph has moved from there. So on the next page, here we go. Now this is supposed to represent a sine curve once again. This first x value you're going to get right there. Now you can see the y value is 0. That's no problem. But to get the x value means how far left or right did that first original point move. The x value for that very first point, everybody, is whatever your displacement is. Okay? The displacement of your curve is going to be your x value number 1. I'll put a number 1 there. Huh? That's your number 1 x value. We'll do an example now in just a moment. Now, how do we get the other x values? All right, well, let's see. This is going to be your point number 1, right there. Your point number 5 is going to go through one complete cycle, and there's going to be your 5th point. Of course, there's point number 2, point number 3, and point number 4, and that last one is going to be your point number 5. The distance from that very first point right down to the very last point, that is 1 period. Whatever the period is, that's what you're going to be graphing. Okay, now read the question carefully, because the question might ask you to graph 2 periods. Okay, well, if they do, we'll put it in there. And if the distance from that first point to that last point is exactly 1 period, and that's what it is according to the graph here, then the distance from your first x value to your second x value, do you see it's been divided into 4 regions? 4 pieces, 4 sections? Well, that distance right there, from the first point to the second point, that must be the period. Oh my goodness, this marker's not good. That must be the period divided by 4. And then, of course, from here to the next x value, that distance is also the period divided by 4. And the same thing from point 3 to point 4, and the same thing from point 4 to point 5. So here's what our strategy is going to be. You calculate your first x value, that's your displacement. Then you calculate the period, whatever that is, from the first point to the last point. You divide it by 4. It's always 4 you divide it by. And you add that onto your displacement. And that takes you up to this second x value. And then you just repeat the process 3 more times. So then you add on the period over 4 to get your third x value. You add on the period divided by 4 to get your fourth x value. And you add on the period divided by 4 to get your fifth x value. It's going to take a little bit of practice, but that's your procedure, okay? So remember, amplitude, displacement, and period. Being able to calculate those from your equation is very important. There's what your table is going to look like right there. There it is. Notice the y values. Starts with a 0, and then you have your max, your amplitude. Then there's another 0, and then you have the negative amplitude, which is kind of like your min, isn't it? And then it goes back to 0 again. The y values never ever change for a sine graph. Now remember, this is sine we're looking at. Now look at the x's. Look at the x's. The displacement, whatever the displacement is, that's your first x value. Then to get the x value for point number 2, you add on the period divided by 4. To get the x value for point number 3, you do the same thing, and then the same thing, and the same thing once again, and that'll give you the x values of all your 5 points. All right, why don't we look at an example? Here on page 25, now they've already done this one for you. This one has already been done. So let's have a look at this one here carefully, and I just want to show you the calculations that they had to go through to come up with this table of values. And they've even drawn the graph there for us. That was a nice looking graph. Now, one thing you're going to find about, I find that the graph paper that's in your book, some of the graphs that they've actually drawn there, excuse me, some of the graphs they've actually have there for you to sketch your graphs on, I think I would have put in more x values along the x-axis. They're all in radians, by the way. Everything is in radians, no degrees here. But some of those graphs, you're actually trying to figure out what the x values are. And that's an important skill, yes, but it can lead to making errors, making mistakes when you're actually plotting your points. Okay, so first of all, let's look at the y values right here. And I want you to see clearly where they came from. Notice the first and the third and the fifth y values are zeros. And that's going to be the same every time. The amplitude, according to the calculation here, and remember now that's your A, that's the 2 right there in front. That's your amplitude. So this graph has a maximum of 2, and it has a minimum of -2. And look at that. There's your max. And then it goes down to -2, and there's your min. It's always the same for the y values. They're easy. They're easy, 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 easy. Now, the next calculation I would have done was this one, the phase shift or the displacement. Now, remember your formula for phase shift or displacement. It's -c over b, isn't it? That's the formula that we learned. Well, c is -pi anyway. So that's negative pi. And b is the number in front of your x. In this case, it's a 2. So negative pi divided by 2. Ladies and gentlemen, there's your phase shift, your pi over 2. And notice that's your very first x value, the very first one. Whatever that displacement is, you pop it right in there for your very first x value. No questions. Okay? Now, if that's your first x value, how do you get to your second x value? and your third, and your fourth, and your fifth. And remember, the total distance from point 1 up to point 5, that very last point, whatever that total distance is, that's 1 period. So we need to calculate the period next, and that's what they've done in this second calculation right there. Okay? That's what they've done there. Now they've put the period before the displacement. That doesn't matter. You can do them in whatever order you like. But remember your displacement, that's your first x value. So you can see they've done the calculation right here. The period is always 2 pi divided by b, and b is right there. Look, b is 2, so they divide that by 2. 2 pi divided by 2 gives you a period of pi. See that? So that's going to be the distance from your point number 1 right up to your point number 5. And the distance between each point, and I like to show this as a calculation. Distance, I wish I had a good stylus. Distance between points, or between x values, if you want to think of it that way, it is between the x values, is equal to whatever the period is divided by 4. So in this case, there's your period divided by 4. See that? That is what you have to add on to the original x value 4 times. So pi over 2, you can even show the calculations if you wanted to. Calculation number 2 for point number 2. The x value is going to be, well, we started at pi over 2. That was the displacement. That's where the first point is. And you add on pi over 4. And guess what that's going to give you? You can do that with your calculators. Most calculators you can type in the pi. If you have a calculator that you can't use the pi's, well, just type in 1 over 2 plus 1 over 4. And whatever you get for your answer, your fraction, just stick a pi behind it. All right, and that'll be the same thing. But anyway, you're going to get 3 pi over 4. And look at that. Look at your second x value. That's what it is. 3 pi over 4. And if you wanted to show the third calculation, it's up to you if you do. I usually show them just to, so that you can see exactly what I'm doing, especially here. So 3 pi over 4. Now, again, you're adding on the same amount. It's still pi over 4. 3 pi over 4 plus 1 pi over 4 is 4 pi over 4. And that's your pi right there. Look at that. See that? There's your third x value, sorry. And if you add on pi over 4 once again, you'll get 5 pi over 4. And if you add on pi over 4 one last time, you're going to get 6 pi over 4, which reduces to 3 pi over 2. And that's the points that they've plotted here. Look, you see that? Now, they probably had a nicer grid than what we might get in some cases. At least you can see all the x values here. Pi over 2 and 0 is right there. You see that? That first black dot, that's your pi over 2 and 0. The next one is 3 pi over 4 and 2. That's that point right there. Then you've got pi and 0. Ta-da, right there. Then you've got 5 pi over 4. There's your x value of 5 pi over 4. And negative 2, so that's going to be your minimum. And last point, 3 pi over 2. There's your x value, and the height of that is 0. And there's point number 5. Now, by the way, if you look at this carefully, you're going to see that there's a pattern going from one point to the next point. So, for example, you might have to go up, well, I don't know, it depends on your graph paper. You might be going up 4 blocks and over 1 block, something like that. Well, to get to the next point, you go over 1 block once again, but you go down 4. And to get to the next point, you go down 4 once again and right 1. It all depends on your graph paper. But you're going to see a pattern. And if you're really, really observant, if you're really careful, that pattern will help you draw the graph as well. Okay? Now, let's see. There is an example here on page 26. Okay. Now, what I'm going to do with you all, I'm going to go through this example with you. I'm going to fill in the x's. I'm going to fill in the y's. There's our calculations right there. We'll do all these. Okay? And then what I'm going to have to do is, now the graph paper that they've got made is down here below. You all see that? Okay, you see that right there? What's the amplitude? 3 over 2. Okay, so it's 1.5. Ooh, I'm going to have to make my screen a little smaller, I think, because I can't quite see it. There's a y value of 1.5 at the top. Oh, all right, well, I'm going to try to graph it anyway. I'll try to graph it anyway. Let's come up with the x and the y values first. Now remember, this is a sine. Notice that carefully. If this was cosine, the y values are different. You'll see that when we start graphing a cosine function. But the first, the third, and the fifth y values are going to be 0, and that's true every time it's sine. The a value, the number in front of sine, is 3 over 2. You can call that 1.5 if you want. And that's your amplitude. And that tells you your other two y values. Here's your max. It's just 3 over 2 or 1.5, whatever you want to call it. See that? There's your max. And the fourth one is going to be your min, and that's just the negative amplitude right here. There you go. There's your max, there's your min. All right. Now, I like to do this calculation x. I like to get my first x value out of the way, and that's my displacement or my phase shift. Now, remember the calculation for displacement is negative c over b. Whatever this is, whatever number I get back from this, that's going to go right in there, my first x value. So let me see. C is 3 pi right there. So I guess negative c is negative 3 pi. Big surprise. Divided by b right there. Look at that. That's a 4. Well, look at that. That's my phase shift or my displacement. You can fill that right in here. Negative 3 pi over 4. What I wouldn't give for a nice stylus. That goes right there. Negative 3 pi over 4. Look at that. You got your first point already. Negative 3 pi over 4 and 0. Now, hopefully, now let me come down and look at the graph, because this is what I'm saying about what they've done in your textbook here. Negative 3 pi over 4. Okay, well, at least you can see negative 3 pi over 4. You can see that. But some of these x values, you notice they're missing, and you might be required to put points there. And like in that regard, you've got to be able to tell what these x values are here, the ones that are missing. And so I wish that more x values had actually been put in the graph here on the x-axis. I'll promise you one thing. Any graph that I get you to draw, you're going to have enough x values there to see what they are. Okay? All right, let me just erase a little bit of that. I want to make some room for myself here now, you see? Okay, now the next thing I'm going to do, I'm going to calculate this, the period. That's what's coming next. Because now remember, whatever the period is, divide that by 4, and that's your distance between your x values. All right, so what's my period? Well, the period, remember, if I look at my formula, I can see that b is 4, isn't it? B is 4. So the period is going to be 2 pi divided by 4. Let me think. 2 pi over 4. Just treat that like a fraction and just reduce it as much as you can. And you're going to get pi over 2. Okay, so that's, remember, the distance from your very first point number 1 right up to your very last point number 5. Boy, it's not much of a distance, though, is it? Pi over 2. That's actually kind of tight. It's crammed in there. But that happens sometimes. That's what we have. So now the distance between points, watch this carefully. I'm going to see if I can neatly put that here. And this would be your next calculation. The distance between points, or the distance between the x values, is the period. I'll erase this afterwards because I need to make some more space for myself. Is always divided by 4. That's your distance between points. So my period is pi over 2. But that gets divided by 4. Now be careful with that because you're dividing with a fraction, right? So pi over 2 divided by 4 is the same thing as pi over 2 multiplied by 1 over 4. And now if you multiply that straight across, remember that's how you multiply fractions, you're going to get pi over 8. Right there. See that? Now you had to add that on 4 times to that very first x value right there. 4 times. Now just use your calculators. Your calculators can do fractions and things like that. And if you wanted to show the calculation, you could. Not really necessary. I'll tell you what, I'll just put, let me put that right here. I have to add on pi over 8 because I want to clear up some more room down there now. I don't have a whole lot of space here. Don't have a whole lot of space. But that's what I have to add on 4 separate times, okay? So I'll just erase that now to get some more space here, because I'm actually going to show you the calculations that I would go through to get the different x values. Now, if you're using a calculator, which I suspect most of you are, you may not even show these calculations right here. But I think I'd put down a few anyway. All right, so let me see. That was point number one. I've got it. I've got point number one. So now for point number two, let's take that last x value, or the first x value that we had, which is negative 3 pi over 4. And remember now, I have to add on pi over 8. And I have to do that 4 times in total. Now you just take your calculators, and you can just type that into your calculator. And hopefully I'll just tell you what I get right here. Negative 5 pi over 8. Now you make sure you can get that with your calculator. But by golly, that is your next x value. Negative 5 pi over 8. See that? Now, here's my beef with the graph down here. Where is negative 5 pi over 8 to? Because I don't see it. Do you see it? Because I don't see it. Well, that means that you're going to have to be able to determine what are the missing x values on that graph paper right there. And I would suspect that the easiest way to do that, for example, if you just look right at this distance right there, look at that. There's your 0. That's x equals 0. And here's x equals pi over 4. Well, halfway in between 0 and pi over 4, that should be pi over 8, shouldn't it? I know, it's a little bit tricky, isn't it? But that right there, that first dash, that's pi over 8. So that is the scaling that they're using here on the x-axis. That's the scaling that they're using. So there's pi over 8. There's 2 pi over 8, which reduces to pi over 4. That point there must be 3 pi over 8. And there's 4 pi over 8 right there. That's actually pi over 2, by the way. That's what that's supposed to show. Here's negative pi over 8. Negative 2 pi over 8, which is negative pi over 4. Here's negative 3 pi over 8. I'll even put that in there, huh? Because that's probably going to come up in our table. There's negative 4 pi over 8, which is negative pi over 2. And look, right there, there's negative 5 pi over 8. Kind of a roundabout way of doing it, but that's what they are. Okay, so when you see in this table right here, negative 5 pi over 8 and 3 pi over 2, there's your negative 5 pi over 8. There it is. Now, of course, after that, you can use a pattern. If you're careful, if you're sure you got that one right, you can use a pattern. Now, for point number 3, you do it again. You are at negative 5 pi over 8. That's where you left off with your last x value. And now you add pi over 8. Again, notice, remember, I'm adding that 4 times. And that will give you negative 4 pi over 8, which is negative pi over 2. If you wanted to, you could leave it negative 4 pi over 8. Might make it easier for graphing. But there you go, negative pi over 2. There's your third x value. You see that? Let's go back and look at the graph. There's your first point. That's your distance. And then to get from negative 5 pi over 8 to negative pi over 2, you're going to jump one more block to the right. I'll bet you a darn the next x value is going to be negative 3 pi over 8. That's one more block to the right, you see? Well, let's do it. Let's actually... Now, that was point number 3. I forgot to put in my 3. Point number 4. Point number 4. We left off at negative pi over 2, and you add to that pi over 8 once again. Now, like I say, you can do this with your calculators, or if your calculator is not able to do that, well, you'll have to get a common denominator. But you're going to get negative 3 pi over 8. And that, ladies and gentlemen, that is your fourth point. Like I said, if you left them all as pi over 8, that might even be easier. You can definitely see a pattern there if you did it that way. You have negative 6 pi over 8 for your first one, negative 5 pi over 8, negative 4 pi over 8, negative 3 pi over 8. I'll bet you the next one's going to be negative 2 pi over 8, which should be negative pi over 4, if I'm not mistaken. So that was point number 4. And so the last one, point 5, is your fifth x value. Now, we left off at negative 3 pi over 8. More than one way to skin a cat. That's what my mother always used to say to me. Add on pi over 8. Look at that, negative 2 pi over 8, isn't it? Which is negative pi over 4. Negative pi over 4. Okay, you ready? Now, the only thing is, I've made my table of values on the top of my page, and because I'm using my computer screen and scrolling up and down, when I scroll down to the graph paper, I can't see my points anymore. Well, I'm just going to read them off my notes here. I have my notes here in front of me. So you make sure you have your graph paper there as well. And let's plot the points. Now remember, the first point that we had was negative 3 pi over 4. That's right there. And 0. So, by golly, look at that. Put a big red dot. Well, it don't have to be red. You put a big dot right there. Okay? Now I got a mess made here of my x-axis. I'm going to erase those points there. I'll leave those values down below, though. There's your first one. There's your first dot. Your first point. Negative 3 pi over 4 and 0. The next one is going to be negative 5 pi over 8, so that's only one block to the right. And 3 over 2 is the maximum. Well, notice the y-axis now. They've got 2 blocks between 0 and 1, so that must be a half right there. That's a half. So that's like 1 over 2. And there's your 3 over 2 right there. Okay? So all I need to do is go one block to the right to get to my negative 5 pi over 8, and 3 over 2 is right there. Look at that. There's my next point. Now, you know what? If you're thinking, you can put in the next points without even counting blocks, even if you didn't know what the x values were on that axis. Because if I had to go 3 blocks up and 1 right, then I promise you to get to your next point, you're going to have to go 1 right again. But instead of 3 up, you're going to go 3 down. And sure enough, look at that. Negative pi over 2 and 0 is right there. Now the next one, I can't quite see it on my screen, everybody. But it's negative 3 pi over 8, which is right there, and you go down 1, 2, 3 blocks. It's kind of down there somewhere. Now you can see it on your graph paper, but I'm kind of missing it on mine. So 3 blocks down there, you put another dot. And for the last one is negative pi over 4 and 0, and that's right there. Now, by the way, something I should have pointed out. Actually, you know what? I can scroll down and put my dot there. I didn't realize that. Look at that. I can move this up and down. No problem. Something else I want you to realize. Go back to the original question. Read it carefully. We just drew one cycle, didn't we? I'm going to draw a nice curve now through those. But look, they never asked you to draw one cycle. They want you to draw 2 cycles, 2 periods. Well, ladies and gentlemen, I've only drawn one. So does that mean I need a bigger table of values? Do I need to make it bigger? No. No, you don't. Because you know what your pattern is from here. It's like 1 to the right and 3 up or 3 down, depending on your point. So I'll bet you that to get my next point from the one I just left off, there was the last one I made, I'm going to go 3 up and 1 to the right. And there's another dot. Now, next one, go 1 to the right and 3 down. Boom, there's another dot. To get your next point, 1 to the right and 3 down. Boom, there's another dot. I could fill in the whole graph like this if I wanted to. Okay, 1 to the right and 3 up. Look, there's my next point. And I could keep going if I had to. 1 to the right and 3 up. There's my next one. 1 to the right and 3 down. That's tons of points. That's more than 2 cycles there. Now, you have to draw it carefully. Remember, these are sinusoidal curves. They're called curves for a reason. No big sharp teeth like that. That's not what these look like. These are nice and curved. So you try to get it as curved as you can. Now, I'm not sure how good of a job I can do with this old stylus, but I'm going to try. There's one part. And I kind of come, that's my maximum right there. Kind of come down and go on down. Oh, I'm going to scroll down. I forgot about that. Scroll down, and there's a curve on the bottom. Notice it's nice and curvy, isn't it? And I come up, and I got a point through there. Now there's one cycle already. There's one complete period drawn already. And now I come up to the top, and whoop, nice little curve there. Back down once again. See that? Now there's kind of like 1.5 periods drawn. And I come down once again. Nice little curve there, and back up. Now you can stop there because technically that's 2 periods right there. That's 2 complete cycles. Notice though I've drawn like a little bit beyond those last 2 points and I put an arrow on the end. That indicates that they go on forever. Now that's kind of a little bit crude because I'm using a stylus on a computer screen, but ladies and gentlemen, there's your graph. There is your graph for this function right there. Now, if you want to make sure you're doing this correctly, go on to that Desmos site. Go on to the Desmos site, and you can adjust things like your the scale on your x-axis, and you can adjust the scale on your y-axis. You could have it looking just like that if you pick the appropriate scale. Okay. Now, I'm going to stop this video there. Goodness, 30 minutes. So I'm going to stop this video here. I'm going to do my next video on the cosine graph. Now, the cosine graph, believe it or not, after you've seen this sine graph done, if you remember this technique, the cosine graph is actually very, very, very similar. Okay? So I'll stop this video there, and I'll pick it up in the next one, and I'll see you later.